Hi, welcome to another episode of Getting Started with Apache Spark. And in this video, we'll take a look at how you can get familiar with the tools and the environments that you have as part of Apache Spark, and keeping in mind that this is an exploratory video for folks who are interested in either developing um, code or solutions for Apache Spark, or even if you're a data analyst or a data scientist, and if you're trying to understand how you can leverage Spark and the shell and the Spark UI, this should be a good introductory video. Specifically today, we'll take a look at these two main topics. So that's the Spark shell itself. I'm going to be using Scala, but feel free to repurpose or recreate this, if you will, with, say, for example, the shell of your choice, like Python. We'll run a few commands to understand the building blocks, if you will, or the core Apache Spark core concepts that I mentioned in another video. And then finally, we'll take a look at the Spark UI itself. That's a web-based UI that you get as part of the Apache Spark distribution. And we'll take a look at how you can infer the details of the job itself, and various actions within the constructs of a job that you have submitted using the shell. So that's going to be a quick video that we'll cover today. So again, the video basically emphasizes or highlights some of the concepts that was introduced in a previous video. So these are some of the core building blocks of Apache Spark, the RDD, the resilient distributed data set, things like how the graph itself is created in terms of the execution, the Spark context, and how we through RDDs we can do transformations and actions on RDDs. So these are some of the concepts that we will cover, but we will do so using the shell. Now, the shell is, of course, a good place for us to start. Essentially, we write a lot less boilerplate code, if you will. Chances are, if you are a developer, it's only a starting point, if you will. It gets us going and understanding how to build solutions using Apache Spark. But in the real world, you'll be writing standalone Apache Spark applications. But if you're an analyst, for example, a data scientist, chances are you will still be using the shell for doing a lot of interactive analysis of data. Even if you're a developer, you'll find that you'll be doing a lot of your initial coding or even ongoing coding, if you will, using the shell. You'll find that you're a lot more productive using the shell than try and convert that into a full-fledged Java application. So if you come from a Python background, or if you're familiar with the Scala REPL, you'll find that it's exactly the same workflow, if you will, that you will use to build Apache Spark applications with the shell. So that's the agenda. So let's actually switch over and start writing some code. Right, so I've just switched over to my demo environment. In the environment, I've already got Apache Spark installed. If you haven't already got Spark installed, suggest you take a look at one of my earlier videos where I show you how you can install Spark in standalone mode. You'll find the details of the video in the description below. So assuming you have everything all set, you can go to your Spark, the folder which you have installed Spark, and run the shell. So Spark shell. Again, I'm using the Scala shell, but feel free to switch over to the Python shell if that's your preferred choice. The other thing you'll notice is that I haven't provided any parameters here. So for example, we could have specified a different master. So right now I'm running using local. All right, so let's give a couple of seconds for the shell to load. And keep in mind the default setting is to display all the messages in verbose mode. So recommend that you keep it that way, particularly when you start developing. And Of course, at a later point in time, you can turn it off so that not just the load, but even when you're typing in commands in the shell, sometimes the verbose mode can be a bit distracting, but recommend that you keep it that way at least for the initial stages. Two things of importance that just quickly highlighting here. So keep in mind when you're running Apache Spark using the shell, the Spark context is created for you by default and set into a variable called SC, that is Spark context. If you are creating your own code for Apache custom Apache applications, then you'll have to create your own Spark context. SQL context is also created for you. In this video, we won't be covering SQL context, but again, worthwhile keeping in mind that it's already created for you. And finally, the last thing is just to quickly point you to the UI, the Spark UI. You'll notice that, again, because we are running it in the Spark shell, it's automatically started a Spark UI for you at this URL. So in this video, we're going to be focusing mostly on the shell itself, and we'll take a look at understanding what's happening behind the scene by looking at the Spark UI. So let's start off with understanding the Spark shell itself. So I'm sorry, the Spark context. So you may remember from the introductory videos mentioned that Spark shell, or the Spark context rather, it's really a representation of the connection to a Spark's execution environment. So you basically need to have the Spark context variable before you can actually make use of the execution into for various things like running jobs, for example. And the Spark context basically represents the capabilities, if you will, of the interface into various capabilities like the scheduler and various others. So as a quick example, if you want to look at the Spark context variable, so SC, and you can uh, type tab, and it'll give you a list of all the available functions there. But we are interested in just a few. So as an example, if you want to know which version of Spark you're running, when you ran the shell, it did display that, but just as an FYI, you can see that in my environment, I'm running Spark 1.4. And you may remember I mentioned that I'm running it in local mode. So for example, if I type in Spark context.master, it tells me that I'm running in local mode. And again, because I've not provided any parameters, it uses, as in I haven't passed any fixed number of cores or processors that the Spark application can leverage. So again, it uses the default settings. And finally, just last thing I'll quickly point out is if you're interested, you can get the name, the app name. So again, this has been preset for you because you're using the Spark shell. But I'm just quickly pointing this out because it'll come in handy as we go through the web, the Spark UI, as well as if you're wondering how did that name come to be set within the web UI. So it gives you some context. All right, so now let's actually switch gears and start exploring RDDs. So RDDs are basically required if you need to do pretty much any type of processing, if you will, any data analytics you're performing, any kind of ETL work, invariably you'll have to use RDDs. So RDDs are resilient distributed data sets, one of the foundations, if you will, that allows for Spark to run in a distributed way. It has built-in resilience, if you will, fault tolerance, and the ability to recover from various scenarios, like say, for example, if a machine is not available, or if the data could not be loaded, there's some corruption in terms of the data, or in terms of accessing an underlying system. It basically handles much of that for you. So simplest way to create an RDD. So we'll take a look at a few examples, but if you wanted to create an RDD in the real world, of course, you'll be loading data from an underlying distributed system, file system like HDFS, for example, or load data from Hive or from Cassandra, various other NoSQL-like solutions. But for the purpose of our demo today, just keeping things really simple. So I'll be loading two RDDs or using two RDDs. One is we'll create an RDD using the parallelize function, and the other will take a look at how you can load or create an RDD from a file. So let's start off first with creating a very simple RDD. So let's create value x is equal to SparkContext.parallelize, and let's say 1 to say 1000. All right. All right, so behind the scene, we have got a new RDD that was created. And again, chances are you will not be using this function in your code. This is almost like a toy example, if you will. So it just allows us to test the functionality of Apache Spark. So in the real world, you're not going to be a very remote chance that you're using the parallelize function as is. So here we have created a new RDD, and a simple way, I mean, this is overly simple how we have just created using a single command. But if I were to show you another example of of creating an RDD, this time around we'll be loading data from a text file. So if I run this command here, first let me actually paste that there. It's loaded that, and you can see that it's created a different type of RDD again because it was based on a file. And if you're wondering where that file resides, so you may remember when I opened Spark, so cd spark, we have a file here that's part of the distribution, so readme file. So we are basically loading that content, and what we are doing is we are using a map function. So you remember we have transformation. Sorry, we are using a transformation function. So you remember from one of my introductory videos that mentioned that some of the building blocks, if you will, of Apache Spark, you have basically transformation functions. So in this particular case, it's a filter, and then you have actions, which I'll come to next. And now let me paste that there. So here again, you can see that it's created another RDD. And if you're wondering how many RDDs there are within the Spark context, basically gives you a count here. So you'll notice that this was the second RDD it created. And then the previous or the first occurrence, we had the first RDD created. All right, so so far we have created a couple of RDDs. So in summary, so far we have created an RDD, which basically comprises of a list of numbers, and then we have created another RDD, which or a couple of RDDs, one to load the content of the text file, and finally do some filters. So again, you may remember from the introduction video mentioned that Apache Spark uses lazy loading. So that basically means nothing's happened so far. Behind the scene, it's created a couple of RDDs, but it's not actually processed the data. So how do you actually know what's happening behind the scene? So a good way to look at it is to understand the data lineage, which is basically a graph of various RDD dependencies. So since we have created a few RDDs, so let's start off with you may remember the first one, which was x. Just created a variable x, and you can type in to debug autocomplete there. So basically, it's telling you that it's there's no other dependencies. Whereas if I take this variable here, so spark to debug string, it basically gives that lineage, if you will, or that dependency. So you may recall that the very first thing was it had to depend on another RDD, which was pulling data from a file, and hence this lineage. So again, it's really easy to take a look at the function.toDebug string to understand how the RDDs themselves are constructed. So again, as part of construction, if you will, of that graph, the DAG, this is quite helpful to understand. That's the toDebug string function. So far we haven't still run anything. I mean, nothing's happened behind the scenes. So let's actually see what's happening. Before I run some actions, let's go ahead to the Spark UI. You may remember that the Spark UI was hosted on localhost 4040. That's the default. Again, pay attention to when your shell starts, the Spark shell, and you'll find out which is the URI that it's running on. So here again, nothing much happening. So we'll see some data come up here in a bit. But again, keep in mind that this is a good UI to do some debugging and understand what's happening behind the scene. So here you'll notice that the application name is Spark Shell. So you remember when we typed SC, that's a SparkContext.app name, it basically had the Spark Shell. And within this interface, we can see all the various stages of the job. So the way the hierarchy, if you will, of anytime you execute something within Spark, it creates what's referred to as a job. And a job behind the scene comprises of, it's broken down into multiple stages, and the stages are broken down into task sets, and task sets internally broken down into tasks. And that's the smallest unit of execution, if you will, within Apache Spark. So far there's nothing here. As you can see, I'll just click through. Let's ignore that for now. So jobs and stages, there's nothing going on. So let's actually run something. So now you looking at these two examples. So you may remember we had a variable called x, and in x let's call collect. All right, and again, it's a Scala thing. You don't have to put brackets, no parameters, so just call collect. So here's the output from the shell itself. So you can see that it's run and fetch the data. So now if I go back here and just do a quick refresh, you'll notice that it's schedule a job, and even on the console here, so it's good to occasionally look at this text here, I mean the log here, and you can see that it's schedule a job, and details of the job. It's quite verbose, so I'm not going to go through each and every one of these, but just the general idea that it's schedule a job, and it's basically using local in this particular case, and it's running the task, and finally it tells you that it's completed running that job, and here it's finally telling you that the job has been finished. Of course, this is a very simple example. In the real world, your jobs are going to run for a long time. I mean, do some big data like processing or analysis. So again, if we go to the Spark UI, we can actually see that these are the list of jobs, and right now it's only got completed jobs. In the real world, you'll see a list of completed jobs as well as jobs which are running. So if I click on this particular job here, so again you'll notice that here it's saying completed 2 out of 2. That's in part because of the level of default parallelism that's been set. So in my PC here, or this virtual machine, what's happened is I mean the default is that it uses the number of cores that's there on this particular machine. So I can go here and type sc dot I think it was default parallelism. Yeah, default parallelism. Oops, default parallelism. Yeah. So here it's basically two. That's because this is my VM and I've got two cores assigned to it, but in your machine it might vary. So hence again, this number that you're seeing here may change. Or will most likely be different for you. We'll take a quick look at another example in a bit where you'll see a different output there. But again, going back to this UI, so if I click on this job here, it gives you an idea in terms of the visualization, if you will, or the dependency. So you may remember a job comprises of multiple, one or more stages. So here this is a really simple job. So it had only one single stage, and within that stage, you can see that this is how the job's been split up. And then finally, we can see all the tasks and how the tasks have been run. Everything here that I've shown you today, it's all running in local mode, so not very interesting. But if you are running in a clustered environment, these are more noteworthy. Again, some of these metrics that you're seeing here might not be immediately useful if you're just starting to develop Spark. I mean, if you're just learning, but in a production environment or as you get closer to completing your development, you'll definitely be paying more attention to some of the other metrics here. So, so we have run one job so far, but let's actually run a few others. So let me go back and change this. So as an example, so within the parallelize command, I can override and provide another parameter for the level of parallelism. So basically, it really implies that I'm providing the number of partitions, if you will, that it can be parallelized. So if I run this right now and run x.collect again. All right, so if I go back to the UI here, so again you'll notice that because I've changed the number of partitions, it's basically trying to split it into 5 tasks there. So anyway, nothing internally would have changed, but right now I'm going to switch over and run the last or collect data from the other RDD. You may remember we've created another RDD that was lines with Spark. So let's actually collect that. Dot collect. Again, it's just a very simple text file. Gives you a quick preview of what that content is. But if I go back and see the job here, so that's the most recent one. Here again, one of the things you'll notice is quite helpful to come and see get a good visualization of the DAG that's been created behind the scene. So again, this was a very simple job. So there was only one stage that was required, and within the stage, it constructed the various RDDs, and finally the collect basically triggers the action which schedules the underlying job. So in summary, again, what we have done so far is we've taken a quick look at using the Spark shell, and in doing so, we've run some very, very basic commands, and we have tried looking at what's under the hood, if you will, in the SparkContext variable, and we have created a couple of RDDs. We have done some really, really primitive transformations, very, very basic transformations, and we have run some actions, and we have taken a look at how you can gain some visibility into what's happening while looking at the Spark UI. So in future videos, of course, we'll be taking a look at all of these in more detail. Hope you like this video. If you have any questions, leave a comment. Thanks. See you on the next video.